Hello there! In this tutorial we are going to be creating a Minecraft style menu in the Ursina game engine. It's going to look like this, and it's a pretty straightforward project. It takes about an hour and there isn't really anything too difficult to do. So if you're a beginner on Ursina, this should be a pretty useful project to understand the entire engine. That being said, if you have no idea about it, I would recommend to check out this other tutorial I made first. It's going to be quite helpful to understand the basics. But yeah, besides that, it should be pretty straightforward. Now, another thing to give some credit, I didn't start entirely from scratch for this project. Instead, I have taken some of the official examples and modified it quite a bit to make it more understandable. So if you want to know where I came from, check out this GitHub page. It's the official example for this same kind of project, although with some slight modification and I think a bit more difficulty built in. But yeah, with that being covered, let's jump into it and I hope you enjoy. Alright, so before we get into the actual code, let's first talk about the theory here. And there are a couple of bits that are a little bit more complicated. So let's talk about all the important concepts we need to understand to make all of this work. Number one, we need an item that we can drag around. That's like the main point of this whole project. And luckily, Ursina makes doing this really easy, because there's an object called a Draggable. And it's called a Draggable because you can drag it around. The name makes sense here. So this part is incredibly easy and we are going to implement this in just a bit. Now, the second part is slightly more complicated because when we drag around items, we don't just want to drag them in random places. Instead, we want to drag and drop them into a specific part so they snap into the cell. And this, unfortunately, is going to be slightly more complicated because there's no inbuilt method in Ursina that makes all of this work by default. Now, that being said, it's not that hard to do because we can still access the position of every draggable item. And when we use a little bit of math here, we can place them in very specific positions that would correspond to the grid. Really, all we are doing is we are taking a position, we're rounding it in a certain way to turn a 0.25 into a 0.2, for example. That's really all we are doing here. And that's basically it for all the really important concepts we are going to need. Obviously, there are going to be a couple of smaller bits, but I guess I can explain them as we go along. So with that being said, let's actually jump into the project. And to get this started, I just want to create a basic window that has a background for the menu. So right now, we are literally going to just create a window with a background image. That's all that's going to happen here. So here I have an entirely empty sheet of code. And this sheet of code is saved in the same folder as a couple of images that we are going to use in just a bit. For example, there's the background image for the menu, there are a couple of textures for the items, and also the cell image, whatever you want to call it. So make sure these are all saved in the same folder or at least in the same project if you use something like PyCharm. Now with that, we can actually get started by creating our basic window and the background for the menu. So the first thing I want to do is from Ursina import star. So we are importing literally everything from Ursina and don't have to write Ursina at the beginning. Now, next up, we have to create our app for Ursina. And this happens by just calling Ursina itself. And then we have to run this app, ideally spell it correctly. And if you do that and you run the code, you can see a basic window. Doesn't really do anything right now, but that is going to come in just a second. So this is the very basic setup you need for Ursina. Now, the first thing I want to add is a background image for the menu. And this is literally just going to be an image, nothing else. So a very, very simple setup. And this is going to happen in a class that I'm going to call BG. And this one has to inherit from entity. And in here, we have to define our init method, call self on it. And in here, we have to create our super init method. And in here, we are going to need 4 different attributes. The first one is we have to define the parent. And this basically means that we are going to attach it to the world. And there are 2 different options here. Number one, you can attach something to a scene or to the world. And this means you are going to place it into a 3D world. But that's not what we want. We want to have this 2D image right at the screen. And to achieve that, we need the other way, which is called camera.ui. And this basically means that we are gluing something on the screen that the player is looking through. So it's right in a 2D space in the center of the view. So next up, we have to define the shape. And this happens with model. And for model, I want to go with quad, so we have a basic square. And this would already be a basic start if we are going to create an instance of this class. So let me call it BG and create an instance of it. And now if I run this, we can see a big white square, well, grayish square. So that's a start, I suppose. But that doesn't really look like a background for a menu. So I want to add one more thing for now, and that's going to be the scale. And all we have to do in here is to define an X and a Y scale. And both of these have to be between 0 and 1, with 1 being the full width. Or well, you could make it larger than 1, but then you would make it larger than the original size. In my case, I want to go with 0.56 and 0.86. And now if I run this, you can see something that looks a lot more like the menu we are going to create in the end. And now you might be wondering, why did I choose those specific numbers? And keep the thought in mind, it's a really good thought. I'll come back to it in just a bit. But for now, there's one thing missing, because if I run this entire code again, we don't just want a plain grayish background, we want to have a texture on it. And for that, we have to load a texture, which is really just an image. And all we need in here is to call load texture and attach a string of the file we want to add. In my case, this is called bg.png. And now if we run this, we can see a much more Minecraft-y looking background color. Cool. So this one is already working quite well. Now, obviously right now, this doesn't really look like much because we just have a static image that doesn't do anything. So we want to add a draggable item to it. And that is actually super easy because Ursina has a draggable object. And this one is literally just an entity that you can drag around. And in addition to that, it has two methods that are being called automatically. And they're called drag and drop. And well, they're named kind of appropriately. Whenever you drag the draggable, the drag method is called. And whenever you drop the draggable, the drop method is called. That should make sense, I think. And along with that, you can also call the position of all of this. There are a couple of ways of doing this actually. But yeah, let's actually implement this, and then I am going to explain how all of this works. So here we are back in the code, and I want to add another class. And I called this one item. And this one has to inherit from draggable. But besides that, we still need to call an init method. And we also still need our super method to initiate the thing fully. That's just a part of Ursina. And now in here, we have to specify a couple of things. First up again, we need a parent. And for now, this is going to be camera.ui. Although we are going to change this later on. I'll explain it then. Now, same thing for the shape. We want a model, and this one should be a quad because we want squares. Next up, I want to give this a color just to see what's going to happen. And for this, we need color and color dot. Let's go with red for now so we can see what's happening. And this is actually already all we need. So let me create an instance of this item. So item is going to be item. Don't forget to call it. And now let's run this. And we have a giant red square in the middle. But the really important part here is if I drag this with my mouse, I can drag it around. So this is already working quite well. Now, obviously, this red square is way too big. So let's scale it down ever so slightly. And for that, again, I need scale. And let's go with 0.1 and 0.1 just for now. And now we have a much more reasonably sized square. So this we can already move around quite a bit. And this is already starting to shape up to look halfway decent. So that's a really good start. Now, along with that, we can make this thing quite a bit more powerful. And this is by adding the drag and drop method. And let's start with the drag one. So it's just a method of the class. It needs a self as well. And then here, let's for now just print, let's call it drop, drag. That would make more sense. And then we can also define a drop method in just the same way. And here we want to print drop. So now let's try the entire thing again and have a look at the bottom left of the screen where you can see the console. And now if I drag it, you can see drag. If I drop it, you can see drop. So this is super useful. And the reason it is super useful is because we can print a ton of attributes of this class in here. For example, we could print self.x. Or when we drop it, we could print self.y. And now let's try this. So if I drag it, we get an X position, and if I drop it, a Y position. So we can tell the specific position of wherever we put this object. So this is that what we are going to use later to position it in a specific kind of grid. That's going to come back, but this is super important. And I guess for now, we can change this ever so slightly. Let's turn this into an F string, so you can actually tell what's going on. And let me just do this for both coordinates, so we can have a much clearer understanding of what's going to happen. And yeah, let's just do this for drop, so I don't show too many things at once. So now let's run this again. And now whenever I drop this square, we can tell an X and a Y position. And in here, there's something that's kind of particular about Ursina, that we don't really get an X and a Y position like in Pygame. Instead, we get like a 0.01 float value. We can still use it perfectly fine, although I don't find it particularly nice to work with. But Ursina was designed for 3D space, and for that, this kind of makes sense. But yeah, it's not a problem, it's just annoying. So nothing to worry about. So with that, we have the ability to drag and drop the item and to run some code whenever that happens, which is something we are going to use extensively later on. But first of all, let's create the actual grid so we can see what we are going to do. And this is going to be the next step, where we are going to create the grid that we are going to place stuff on. And for that, Ursina has quite a few methods that we can use. The most important one is called texture scale. And let me explain what happens here. Usually when you apply a texture to an entity, you just stretch the texture across the entire thing. So the texture covers the object entirely. But sometimes you want to repeat a texture certain times, either on the X or on the Y axis. So maybe you have some roof tiles and you want to have multiple shingles. And in that case, you just want to repeat a certain texture multiple times. And this is super easily done in Ursina, and this is done with the texture scale. Because for this, you can specify an X and a Y value, and then a texture is being repeated. And that is something we can use for the grid quite well. And this is also something we can use later on to place items into the grid. I guess I come back to that later on. But yeah, let's actually implement this, and let's see how it's going to look. So here I'm back in the code, and let's create another class. And this I think I called grid, but the name again really doesn't matter. And this one just needs to inherit from entity. And in here we need the usual. We have to define an init method. It needs self. Then we have to create a super init. And in here we need the couple of usual parameters. And let me just copy them from the item because I'm lazy. So parent is camera UI, model is quad, the usual. Now in here, now we want to have something else as well. We want to have a texture first of all. And the texture is just going to be the box of one of the cells in the grid. You'll see in a second what I mean. And to load a texture, we need load texture. Naming is really a strong suit of Ursina. And how I call this is box.png. And now let me actually create an instance of this class. Let's call it menu grid. And this one needs grid. And now let's run all of this. And here you can see what I meant. Now we have a kind of boxy thing around our entire background. Right now, it's way too big. So the first thing we need to do to fix this is to apply a texture scale. And in here, we need a tuple with an X and a Y number. In my case, I went with 5 and 8. And let me just run the code to show what this is going to do. And there we go. So now instead of having one texture across the entire thing, we are replicating a texture multiple times to create a grid. So this one is looking much better. Obviously right now it's way too big. So let's scale it down, which happens with the scale property. And in here, I went with 0.5 and 0.8. And now let's run this again. And there we go. Now we have a much better looking grid. Two really important things here. That these numbers here and these numbers here look similar for a specific reason. That to get squares, these numbers have to correspond with each other. So that when you divide one by the other, you always get 0.1. And that way, each of the cells is exactly 0.1 units high or wide. So that's quite important. And also, what I mentioned earlier, these numbers here I have chosen, or rather I have chosen these numbers here because they are ever so slightly larger than these numbers here. And essentially, these numbers up here for the background are just a tiny bit larger to create a grid between the cells and the outside of the menu. That's literally all it's for. So you could have made these numbers a little bit smaller, but then you wouldn't really have a padding around the menu cells. So this, I think, looks quite nice. So now the important question becomes, how can we actually connect these two concepts? That we have a draggable and we have a grid, but right now they don't work together at all. So this is going to be the next step, where we are going to create a connection between the grid and the items. Now, to make all of this work, we are going to need a couple of concepts. And I guess the best way to achieve this is to go through them step by step. So let's start with the simplest one, that I want to establish a specific connection between the items and the grid. So that the grid is essentially the parent class for all the items, so we can access all of the items from the grid, which is going to be quite important. And most of the time in Python, if you had a task like this, you would just create another attribute in the class and then add children to it. So we'd have like self.items and then a list of all of the items in the grid class. But in Ursina, that's not quite how it works. Instead, what we have to do is to change the attribute of the parent attribute. And that way we can create a parent class automatically. And it's perfectly fine to use a class that we created ourselves in here as a parent. It's actually really powerful. And let's actually demonstrate this. So here we are back in the code. And let me actually minimize BG so we know what's going to happen. So whenever this item is going to be created, I want this to be a child of this grid class. And now just to explain what I just said in the intro, if you are doing this in any other Python module, you'll probably go with something like self.items is going to be a list of item. And then you just add multiple items depending on how many you need. In Ursina, that doesn't work like that. Instead, what you want to do is change this camera.ui. And this one needs to get some kind of, let's call it container. Now, what is this container going to be? It's going to be whatever we pass into the item when we create the instance of it. And let me just get rid of this item here because we are not going to need it anymore. Instead, I only want to create items within this grid class. So let me actually create a whole new method for that. Let's call it add new. And this one is just going to need self, nothing else. And in here, literally all we have to do is to create an item. And this item is going to need one parameter, the parent or the container. And the container is just going to be the class itself. So literally all we have to do is to pass self in here. And well, that's literally all you have to do. You don't really have to add the item to any kind of list. Ursina does all of that for you. So as long as you created a parent for this class and the parent is specified to be this grid, you have already attached it. So now when we run init on this class, let's call self add new item. And let's see what happens. And here we go. Now we still have our draggable item, but now it has picked up the scale from the parent container, which is 0.5 and 0.8. So this thing now has a weird scaling, something we can fix in just a bit. Now, obviously, this still doesn't help us all that much, but it is a really important step that we can use later on. Because now what we could, for example, do is in the grid, we can call print self.children. And let's run that. And now at the bottom, you can see this one here. We have a grid item as a child of it. If we added more to it, we would have more of that. And later on, we can cycle through them and get their information, for example, their position, which is very, very powerful. But all right, let me get rid of this part for now. And now the first thing I want to do is to fix the scaling of this item. And for that, we first have to get rid of the scale property at all because we don't need it anymore. And instead, I want to specifically target the scale X and scale Y because the code here is going to be slightly longer. And fortunately, we can do that. All I need is scale X and also scale Y. And now in here, we want to figure out a specific thing. We want to know from this information how we have to scale this item here, because this is going to tell us how big it needs to be. And fortunately, we can access this information from the child. All we really need for that is to get the container, so the information we passed in here, in this case the grid, and from this container, we can access the texture scale. And this is going to be a tuple. The tuple we have specified in here, so 5 and 8. And for x, I want the one with number 0, so the x scale. So this one right now would be giving us a 5. So not great yet, but what we can do is we can separate this by 1. And really all this means is that the entire width of this thing is going to be 1, and it's going to be separated into 5 different parts. So when we have the width of each individual item, it needs to be 1 divided by 5, exactly what we have done here. So now if I copy this and change it to a 1, and now let's run the code, we can see now we have a perfectly sized rectangle, because we are literally using the scale from the parent to define its size. But there's one thing, I don't really like that this thing is exactly on the borders of it. So I want to make this draggable item ever so slightly smaller. And this we can also achieve quite easily. All we need to do is to make this number here ever so slightly larger. So you can really just put it into brackets and then multiply it by 1.2. And do the same thing for the number below. Obviously change it to 1. And now if you run all of this again, you have a draggable that fits much more nicely into each of the cells. Obviously it still doesn't snap, but that we are going to come to in just a bit. So with that, we have a basic setup to connect the two. Obviously that still doesn't help us to actually place the item. And this is going to be the next part that I really want to work on. That whenever we drop the item, it is going to snap into a specific position. And for that, we really have to think about the coordinate systems that we have for this setup. And right now, we only have one coordinate system, and that's the actual grid itself and its x and y position. And just to be clear here, this thing right now is a square that has a coordinate system that goes from 0 to 1 and from 0 to -1 in the y-axis. And these positions we can measure very easily. I'm going to demonstrate that in just a second. And now all we really have to do to place items in a specific position on top of that is to imagine a grid on top of this thing. And we don't actually create any specific method to create this grid. Instead, we are just going to round the numbers in a specific way. So for example, if a number is 0.25 and 0.1, we are going to round these numbers in such a way that they're going to snap in a specific position. So the logic here, I think once I actually implement it, is going to make much more sense. Let's go through it, but this might be a part you want to watch twice. It's slightly more complex. But let's go back into the code and let's have a look at this. So here I'm back in the code, and we still print x and y whenever we drop the draggable. So let's run this code and let's see how this looks. So whenever I drop this right now, we get x being 0.0 something and y being 0.06. Now if I go to the top left, we get x being negative 0.4 and y being 0.4. And just to explain these coordinates, all the cells we can see right now have a coordinate system that goes from 0 to 1 and from 0 to -1. So if I move this draggable to the top left, we can see something like negative 0.5 and 0.5. So we're moving 0.5 to the left and 0.5 up. And the really important thing here is that the origin of this system is right in the middle of this grid. So from this position, we move -5 to the left and 0.5 up. And again, in Ursina, remember, if you go up, the y number increases. This is the exact inverse from Pygame, for example. So this is already giving us a certain kind of coordinate system that we could be working with. Although I really want to make one change, that right now the origin point is right in the middle of this thing, which is kind of a pain to work with. Instead, I want to have my coordinate system start right in the top left. This is going to make our math significantly easier. So let's start with that. That I want to take this grid and change the coordinate system to the top left. And for that, all we have to do is to get the origin and give it an attribute of -0.5 and 0.5. And now if I run this, you can see that now we have moved the coordinate system right into the middle of this thing, which, well, it's a start, but not great yet. So now to adjust for this change in origin, we have to move this entire thing to the left and up, which we can do very easily. So all we have to get is the position of the thing. And then here it's going to be 0.25 and 0.4, which is exactly going to be half of the scale. So now if I run this again, now we're back to our normal grid. But the really important thing here is you can already tell it actually here that our draggable item, if I now leave it roughly at the top left, we can see numbers that are basically 0 and 0. And this is really important because now if I go all the way to the right, we get x being 1 and y being roughly 0. If I go all the way to the bottom, you can see 0 and y being -1. So these are some numbers we can use very easily to place the item in a specific spot. Because all we really want, let's say this is grid 0 and 0, then we can place it at position 0 and 0 and just round these numbers a tiny bit. Same with if we put this in the second spot, now we need something like x being 0.2 in the top left, which is going to make our math significantly easier. And well, let's do that actually. So whenever this item is being dropped, I don't just want to print the position, I want to put it into a specific position that is defined by the parent. And now in here, we have to do a little bit of math. And I think it's best to illustrate by printing exactly what we are doing. And let me comment out the other 2 bits so they're not going to be annoying. So first of all, let's start with self.x, the number we already have. So if I run this and I drop this thing here, we get 0.1. If I put it into the second cell, we got 0.3 and so on, 0.5, and all the way to the right, we get 0.9. So we can get an x position. Now really all we have to do is to round this number in such a way that we get very clean, predictable numbers. So for example, that this first one here, instead of 0.1 with a ton of numbers, just becomes 0.1. And actually, just to make the math a little bit easier here as well, let's change the origin point of this draggable item as well. So let me close this. And let's change the origin point here as well. That's going to make our life a good bit easier. And here, I want the origin to be changed. And in here, you might be tempted to go again with negative 0.5 and 0.5. But that wouldn't exactly work. Let me actually demonstrate why. So right now, we already start in cell 0 and 0. But our cell is glued to the top left. But we want to have a little bit of an offset, something like this. And the problem here is that we multiplied the scale of this cell by 1.2. So it's slightly smaller than the actual cell. And we have to account this for the origin. So I want to have the origin slightly outside of the actual item. And well, all we have to do is to divide this by 2, and then we have the right number. And 1.2 divided by 2 is 0.6. So now, there you can already tell. Our grid is starting to enclose the item. So now if I just drag and drop it, we get a specific number. I have no idea where the 0.5 came from, I'm really sorry. That seemed to have been a bug, no idea. But usually this works really well. So we get 0, we get 0.2, we get 0.4, we get 0.6, and we get 0.8. So all we have to do now is to round these numbers in such a way that they're always identical. So we don't get 0.196 and so on. Instead, we get 0.2. That's all we really want. And for that, unfortunately, we have to do a tiny bit of math. So let's go through it one by one. First of all, this number here, I want to turn for now into an integer. And why do I want to do that? Well, I want to have this number clean and rounded. So right now, I want to have this integer between 0 and 4, because that way we can just divide it by 5, or the number of x cells that we have, and then we would always get a clean number. So let me print this. This should kind of almost work. So we get 0 and 0. We still get 0 and 0, but if we get to further to the right, we get 0.2 and so on. Eventually we get a larger number. So right now, this doesn't exactly work, but you can kind of see the principle, I think. But this number obviously is way too small. So we have to get this number to be a little bit larger. And a simple thing you can start by doing is to multiply this number by 5. So let's say if this number here is 0.2, we multiply it by 5, then this entire thing would become 1. And we then divide this by 5, then we will get 0.2. So now let's try this again. This should already get us quite a bit closer to it. So we get 0 and 0, 0 and 0 still, now 0.2, 0.6, and 0.8. So this almost worked. We're getting much closer. And well, here is the slightly dodgy part of this project. Because the next step on how to make this work, self.x, I put in never brackets, and I have added self.scale x divided by 2. So we are always adding half of the item's width. And well, now if I run this, and we get 0.0, 0.2, 0.4, 0.8, 6, and 0.8. So this is actually working really well. Now, well, I gotta be honest here, I have no idea why this works. When you actually run these two numbers, you get really unclear numbers. And I think if you get to really high numbers, this might start to break down. But we're talking really high numbers, like if you have hundreds of cells. But I guess in our case, this is still working, although not great. Ideally, try to understand what your code is doing. But, well, it is also working, so that's a good start. So now instead of printing this number here, I just want to set self.x to be this number. And, well, now, whenever I drop this, so even if I print it right in the middle, it snaps back to the specific thing. Because we are rounding it in such a way that whenever we drop it, it drops back to it. Obviously right now, just in the x-axis, but this is working quite well. So now we can just do the same thing for the y-axis. Change self.x to self.y. And all of these x's to a y. And then obviously this here from a 5 has to be an 8. And one more really important part. Since the y-axis, if you go down what is negative, this shouldn't be plus, it should be minus. So now let's try this again. And now I can just place stuff, and now it always snaps towards the specific grid that we are going to work with. Yeah, this is actually working super well. So nice. And yeah, so this bit here is a little bit of tricky math. And basically when I figured this out, it was just trial and error, and I still don't fully understand it. So later on, if you make this your own project and you make this much larger, be aware you might want to work on these numbers here. But yeah, I guess at least for now, it at least works. So that's a pretty good start. Now there's one more problem that I really want to address. And that is right now we can drag this item anywhere on the screen, which not great, it's a bit weird. So I want to give it some kind of constraint. And to fix it, I want to add another method. And let's call it menu constraint. And when we define menu constraint, needs a self. And here the logic is actually super easy because we know in our menu grid, we have specific coordinates that the thing starts at 0 and goes to 1 on the x-axis and goes from 0 to -1 on the y-axis. So all we have to do is that if we go outside of these numbers, so self.x is smaller than 0, or self.x is greater than 1, or self.y is greater than 0, or self.y is smaller than -1. So if any of these are true, then let's say for now we want to print outside. And let's see if this is going to work. So I can still move my item around, but now if I place it outside, we get outside. So we know whenever it is outside, which is, well, at least a step in the right direction. Cool. But now I don't just want to print something, instead I want to return the item to its original position. So whenever we drag it outside of the menu, it just goes back to where it started from. So the first thing we have to do is to uncomment the drag part, because whenever we drag the item, we want to get the position where it started from. So let me get rid of those two. And all I want to have in this method is that whenever I start dragging, I want to get the position. So for that, I'm going to define a new attribute. Let's call it xyPos. And all that this one is self.x and self.y. So whenever we start dragging this item, we get the position and store it somewhere so we can use it later. And well, then down here, if we are outside of this position, we are going to place the item back into the position where it came from. So self.x is going to be self.xyPos, the first one. And then for self.y, it's going to be self.xyPos and 1. And well, that's it. Let's run it now. So I can still move it inside, but if I go now outside, it snaps back, but I can still move it inside of the grid. So that's literally it. Now we have the ability to place this item inside of this grid, and that's working really well. Cool. All right, and with that, we have the really complicated part of this project out of the way. I guess the next step is we can make all of this look a little bit nicer. And what I mean by that is that when we have our item, I don't just want to have a red item, I want to have an actual texture. So let's work on that. And the logic here is going to be quite simple. When I create a grid class, I'm going to import a couple of textures, and each item is going to get a random texture. That's basically going to be it. So here we are back in the code. I have minimized everything to make it a bit more readable, and I want to work in the grid. And specifically what I want to do here is to create a new method. Let's call it import textures. Need self and nothing else. And in here, I want to do two things. Number one, I want to import a couple of textures. And number two, I want to import all of these textures to a list so we can actually use them in the grid itself. But let's go step by step. First of all, I want to import a texture. Let's start with the grass one. So the grass one, I need load texture again. And this one I have called grass.png. And well, now we have to do the same thing for all of the different textures we have. For example, there is a brick one. This one needs load texture with brick.png. Then we have stone, I think I called it. I'm terrible at typing. Load texture, this is stone.png. Oh, actually, perfect naming. This is called rock. Let's call it rock. And the final one I call dirt. And for this one, we need load texture and dirt.png. So in total, we have 4 different textures. But right now we have imported them, but we don't really do anything with them. So to fix that, I want to create a class that I call textures. And in there, I just want to add all of these different textures. So rock and dirt. Obviously, you could have just loaded all of these textures straight into it. Would have been the same outcome, but I guess this one is a little bit more readable. Now, all I want to do is when we initiate this class, I want to run this method. So import textures. And well, that's all we really had to do to import all of the textures. So now inside of this class, we can use this self.textures to get one of the textures. So we can close this one. And now, whenever I instantiate one of these items, I want to add a random texture to it. So I have to open the texture and give it an actual texture. So let's put it right below color. So texture, and let's call this type. Can't think of a better name. And this has to be given to the class when we initiate it. So this for now is all we need. And now when I create an item, let's just start with just the first one. So I want self.textures and number 0. So now when I run this, we can see, okay, this kind of works. You can see some grass-ish looking thing. And the problem here is that this red color and this texture, they're working together to create the color. So we're basically tinting the entire texture in red when we do this. To fix that, all we have to do is to turn this into white. And now let's run this again. Now we can see it. Now this is looking much better. Cool. So now we have a grass texture. But I don't just want to always have the grass texture or the one with the index 0. Instead, I want to have a random one. So to do that, we need random numbers. So I have to from random import rand int. Actually, choice. So that we can pick a random item from a list. And that literally is in here. We need choice. Put this in there. And now whenever I run this, okay, same thing. Now we get a brick texture. We get a grass texture again. Grass texture. I'm being very unlucky with this. There. Now we get a stone texture. So now we get a random texture every single time we run this. Cool. So this, I think, already makes the entire thing look quite a bit nicer. Yeah, you can play around with the looks of this forever. I'm going to keep it simple. So with this, we have made the entire thing look substantially better. There's still one big thing missing, that we only have one item and we can't add anything else to it. So let's work on this bit. And in here again, we are going to need a couple of different concepts working together. Number one is we have to look for keyboard input. Number two is we have to be able to use that keyboard input to add an item. And number three, the actually important bit, is that we have to find a free cell to add the item to. And that we are going to take care of in just a second. But let's go through this step by step. So here I'm back in the code. And the first thing I want to do is to check for keyboard input. And this can be done very easily in Ursina. All we need is define an input function, and this takes one argument, the key. And this is being called automatically by Ursina. So we don't have to call it ourselves. We just have to specify what we are looking for. And I want to look for a specific key. In my case, I went with the key A. But you can basically add anything in here. And whenever this is pressed, I want to get my menu grid and call the add new item method. So this thing here. And once we have that, we have a new item. So let's run this. Let me move this thing to the side. And now I press A, we got another one. And now we can just add more and more items to this. And the random method really isn't very random. Okay, now it gets better. Cool. So now we have random items. The problem here now is that when I keep on pressing this, it always adds new item on top of this thing. So this is something we do have to work on. Also, I can add one thing on top of another. And this is also something we are going to address in a bit. But for now, I want to make sure that whenever I add a new item, this grid first finds an empty cell and only then adds a new item. And to make that work, when we create a new item, we have to give it a position. So I want to add another argument into this. That's going to be the position. And that means also when we create this thing, this also needs a position. And now we have to integrate this position into our grid, which, well, fortunately is very easy. Because all I have to do is to get, so I imagine this to be a tuple with an x and a y portion. So right now we take the x value, and now all we have to do is to multiply this thing by 1 over the texture scale. And this number here would always going to be 0.2 because the texture scale for the x is going to be 5. So any number we have in here, we're going to multiply by 0.2. So if this is 0, it's going to be 0 anyway. If this is 1, this entire thing is going to be 0.2. If this is going to be 2, this entire thing is going to be 0.4. And that way we basically do the same thing as we're doing here. We are just going to create specific numbers that don't really change. And then we have to do the same thing for the y portion. So let me copy the entire thing and just change this to a 1. And now we get the same thing we have done for the y. So I hope that makes sense. And now let's test the entire thing. So when I call the position, I'm going to define pos to be, let's start with 0 and 0. And let's run this. And we are in the top left. And if I add a larger number, let's say 2 and minus 4, we get 2 from the left and 4 from the top. So this one is working pretty well. Cool. Now, the obvious problem is we are always going to add a cell to this position here, which we don't want. Instead, I want to find a cell that isn't occupied yet. And this is something we can do, but it does rely on a couple of different parts. So let's go through them one by one. Essentially, all I'm going to do to make this work, I'm going to create a grid of all the cells that are possible in our grid. And that's going to be one list. I call this all cells. Now, then I have created another list, and this is called taken cells. And this is literally just a list of all the cells that are already occupied. And all I do then is I compare both lists and see which field is empty yet. And then I am going to use that cell, and I have an empty cell. So that's literally the entire logic. So let's actually go through this step by step. So here we're back in the code, and instead of a specific position, I want to create a new method. Let's call it self find free cell. And let's put this right below, define find free cell. Does not need any arguments besides self. And we have to start with a list of all the possible cells that we can have. So this is literally just all the different cells that are possible. And for that, I'm going to use list comprehension. And for this, I have used a vector 2, so a two-dimensional vector with an x and a y, which I think makes sense. And now I just want to get all the possible y and all the possible x positions. So for y in range from 0 all the way to 0.8, and we want to go in the negative direction. And for all of this, also for x in range 0 and 5. That is literally all we needed. Let me actually illustrate what's happening here. So let me comment out add new item, and instead I want to return all cells and then print pos. So what we're doing right now is whenever we run this method, we are going to create all the possible cells in here and return it. So it's being stored inside of position, and then we are printing it. I hope that makes sense. So now if I run this, we can't see any item, but now I've pressed A, and you can see a ton of different vectors that start from 0 and 0 and go all the way to 4 and -7. So these would be all the possible cells that we can use. But obviously, we don't just want to print them, we do want to use them. So this will be the first step. We have all the possible cells. So next up, I want to find my taken cells. And this one is actually also going to be fairly simple. Essentially, I want to first look at all of the children. So all the items we have created earlier. And I want to cycle through this thing. So for child in self.children. And now I have to find a method to get the position of this child, or the specific grid position. So we need a vector like we have done above. And for that, I'm going to create a specific method inside of the child class. So let's call it child get cell pos. So really all that's happening here is we're cycling through all of the children, and we're calling the get cell position. And this one is going to give us a vector with the x and the y position. So all we have to do now is to actually create that. So I want to get cell position, and it doesn't need any arguments. And in here, I want to figure out what the cell position of this thing is going to be. And for that, we're going to need an x and a y position. And at the end of it, we want to return a vector 2 with x and y. So now let's define these two variables. And this is going to be actually quite simple. All we need is self.x, and multiply this by self.parent.texture scale in the appropriate axis, so 0 for x. And this one would then give us the specific point it's on in the grid. Obviously, this then has to be turned into an integer because we want to have clean numbers. But that is essentially it. Now I can just copy this thing for y and change the x to a y as well. And with that one, we just get a specific position. So with that, we have all the taken cells and all the cells possible. And now with that, all we have to do is to compare these two different cells. And well, this just means for cell in all cells, if cell not in taken cells, then we want to return that cell. So the logic here, I think, makes sense. We look at each cell in all the possible cells, and we check if this cell does not exist in any of these taken cells. And if that is the case, we're going to return the cell that is not in any of these cells. And then the code is going to end, and we are good to go. So let me get rid of this. And now this should actually work. Let's try. So I run the code. we already get 1 because we're calling it once, but now let me try it again. And this did not work because we're still adding it on the same position. And you might have already spotted a mistake here. I do not call the get cell position. I just named it. So this one obviously would never get a proper position. So now let's try this again. And here we go. Whenever I press A, I'm going to add a new item to it. And here's something slightly weird about Ursina. If I had more of these grids, at some point we get a weird texture error. I don't know why this is happening. If you start to drag this around, you get a slightly different thing. You can still drag them, you just can't see them. Honestly, I have no idea why this is happening. Might be a bug. So, but if you keep on adding it, it still works. It's just a bit weird. Oh yeah, and if we have too many of these, the entire thing crashes as well. So not great. Don't worry too much about it. But the one thing we do have to worry about is some kind of failsafe if we have too many different cells. And all I did for this is if the length of the taken cells is greater or equal to the length of all cells, then I want to return false. And now when we add a new item, I just want to check if this thing exists at all. And if that's the case, only then do I want to create a new item. So if we return false, this thing is not going to evaluate and we're not going to add anything new here. So should still work. And there we go. This is still looking good. Cool. So now we can also add new items and things are still looking quite well. Cool. So let me close all of these again because we only have one more thing to add. And that is, let me add a few more, that whenever these two overlap, I want them to switch positions. So when I drag this brick on top of the grass and drop it here, I want the grass to go to where the brick used to be. And let's implement that. That's also actually not too much of a difficult thing to add. So let's talk about that part. All we really have to check in here is that whenever we drop one of these items, then we want to check all the children in the grid. And if two of them are overlapping, we know that we dropped one item on another. So then on this other item that we dropped it on, we want to move this to where the other item used to be. I hope that makes sense. And yeah, that's actually all for the logic here. Let's actually go into the code and let's have a look at this. So here I am back in the code and I want to have a look at my items. And okay, this is also getting quite extensive. Let me minimize a few things so it's not getting overwhelming. So I want to look at the drop. So whenever we drop an item, I also want to check if it's overlapping with something else, because then we know we have dropped the item on another item. So let's call this an overlap check. And let's put it right below so we can see how they work together. So def overlap check. It needs self as usual. And in here, we have to think about a couple of different things. Number one, whenever we drop this, we want to check all the children inside of the grid, which we can do very easily. We want to go for child in self.parent.children. So essentially, from this item, we go to the grid and we look at all of its children. And now in here, we have to check if one child is overlapping with another child. So if child.x is equal to self.x and child.y is equal to self.y. So this logic here might be slightly confusing, I think. Effectively, we have a child and we have our self. Both are items. But when we cycle through all the children, we look for all the possible existing items. Whereas for self, we look for this item itself that we currently have selected, so the one that we have dropped. So that way we can distinguish between the child that already existed and our own item that we just dropped. Once we have that, all we have to check is if child is equal to self. Then we just want to continue. However, if that is not the case, I want child x to be where the self used to be. And this we already have. We have xy pos, and this is going to be 0. And then we have to do the same thing for y, except with 1. And let me explain what happens here. We first cycle through all the children in the parent, so all the possible items. And then there we check if any of the children is overlapping with the item we just dropped. Now, if the item we just dropped is ourself, we just don't do anything. If that is not the case, we're going to put the child where our item used to be. Now, this line here is actually really important, because if we didn't include it, Ursina would always add both the child and ourself to this original position. So we have to find some code to ignore the child itself. So this one here is quite important. And let me put it on the line before. I think this looks a bit cleaner. But okay, let's try this. Let me add a few more. This still works. That's a good sign. And let's move this brick to this dirt sign. And there we go. We can move the two around. And yeah, there we go. We have a properly working menu system thingy. And we can just move stuff around and we are good to go. Yeah, that was pretty much it. I hope you enjoyed this tutorial.